Math 7 Unit 8, Lesson 1. In this lesson we'll be doing an introduction to statistics and talking about measures of center. Now the measures of center that we've learned previously include the mean, the median, and the mode. Now the mean is your equal share, the median is the middle number, and the mode is the one that happens most often. Okay, let's talk a little about the mean first. One way to remember this, you've been told, don't be mean, you need to share. The mean is the equal share. You do the sum, which is what you get when you add everything together, and divide it by the number of numbers. For example, if your numbers are 1, 2, 3, 4, 4, 5, 5, 5, and 8, you would add them all together, get 37, divide by 9, because there are 9 numbers. That gives you 4.1 as your mean. Now we usually go to one more decimal place than our actual data, which a mean is, it's an average. You can get a family has a mean of 2.3 kids. Now there aren't any 0.3 kids out there. They're either a kid or they're not. But with averages, you can get parts of things that can't actually be cut up. Okay, with median, it's the middle. It's the middle number in order if there's an odd number of elements, and it's the mean of the middle numbers in order if there are an even number of elements. So for example, an odd number of elements, same list as before, 1, 2, 3, 4, 4, 5, 5, 5, 8. The middle number is 4. There are 4 elements below and there are 4 elements above. Now, because there are 9 elements, you can find the position of the median if you take the number of elements plus 1 divided by 2. In this case, the number of elements is 9. 9 plus 1 divided by 2, that's 10 divided by 2. It is the 5th element. So 1, 2, 3, 4, 5. The 5th element is 4. Okay, if you have an even number of numbers, you take the 2 in the middle and add them up and divide by 2. You take the mean of the middle. Now you can use this same n plus 1 over 2 to find out the position of that element. 4 plus 1 divided by 2, that's 5 divided by 2. That's 2.5. So it's the 2.5th element, which is halfway between the second and third. So we've got 1, 2, 3. It's halfway between the second and third element. So we add them together, divide by 2, and we get the median. So the median is always the middle point. If there's an odd number, there's just one number in the middle. If there's an even number of numbers, there's 2 numbers in the middle, and you have to find the mean of them. Okay, the mode is the most often number, or 2 numbers that occur most often. If we get up to 3 numbers, we would no longer call it a mode. By the way, if a data set has more than one mode, it could be called bimodal, having 2 modes. Anyway, on this first set, there are 3 5s that occur, and that happens more than the 2 4s or one of each of the rest, so the mode is 5, most often occurring number 5. The second example, with just the numbers 1, 2, 3, and 4, there is no mode because everything happens only once. There is no most often occurring number. All right, the mean we just talked about. It's a measure of center that shows the equal share. All numbers in a set are summed and divided by the number of elements in a set. And the example here for the numbers 1, 3, 5, and 5, it is 1 plus 3 plus 5 plus 5, all divided by 4. 3.5 is the mean. The median, it's the measure of center that highlights the middle value, having half the elements in the set greater than and half the elements less than. So it's trying to cut the set in half right in the middle. So in this same set, 1, 3, 5, and 5, It's right in the middle, which is going to be right between 3 and 5. So we do 3 plus 5 divided by 2. We get 8 divided by 2. The median would be 4. The mode. It's a measure of center that highlights the most common element. So in that same set of numbers, 1, 3, 5, and 5, it's 5 because it happens the most frequently. Okay, example 801. Determine the mean, median, and mode of each set of quantities. Okay, for the mean, we will have to first add all of these numbers together. So let's pull in our handy dandy calculator. We've got 5 plus 11 plus 6 plus 13 plus 11, and that is 34. And we're going to take 34 and divide it by 1, 2, 3, 4, 5 numbers, and that's 6.8. So the units on these are all miles. So this is 6.8 miles as the mean. I need to have a little bit more space because I've still got to do the median and the mode. Okay, for the median, I need to put the numbers in order and find the middle number. First off, since there are 5 numbers, in order to find the median, I need to find the n plus 1 divided by 2. That's 6 over 2. I need to find the third number. Now, when I put them in order, technically you order all of them and then you just find your way to the middle. But since I know it's the third one, I actually have to go to the third number. So the smallest number here I see is 5. The next smallest number is 6. And then it looks like I've got 11 twice and 13. However, since I knew it was the third one, I actually could have stopped right there at 11. So the median is 11 miles. Okay, the mode. The mode is the most often occurring one, and just a quick look at it, 11 happens twice, everything else only happens once. So this first set, the mean is 6.8 miles, the median is 11 miles, and the mode is 11 miles. Let's move to our next example. Example 802. $3.50, $5, $4.25, $9.75, $6.50, and $6. First, starting with the mean, we are going to need to add all of those numbers together. So bringing back in the trusty calculator, we've got 350, 3.5. Why did the point not go in? Let's try that again. Maybe the calculator is not so trusty. 350 plus $5 plus $4.25 plus $9.75 plus $6.50 plus $6. And if I've typed everything incorrectly, that's 35. And that's 1, 2, 3, 4, 5, 6. 35 divided by 6. Divide 6. 5.83. Generally, you round to one more decimal place than your data. And this is in dollars. So it's $5.83 plus 3 mils, I guess. All right, let's take a look at the median. All right, for the median, since there are 6 elements, 6 plus 1 divided by 2 is 3.5. Our median will be between the third and the fourth one. The smallest number is 350. The next smallest number is 425. The next smallest number looks like it is 5. The next would be 6. And I've actually gone far enough I can do the median, but I'm going to finish it out. Okay, it's between the third and fourth one. 1, 2, 3, 4. Between 5 and 6. Now between 5 and 6, we could do 5 plus 6 divided by 2, which is 11 divided by 2, or 5.5. Now I would expect that you could actually do that without necessarily needing to add them up and divide by 2. Because you're asking what is the midpoint between $5 and $6. Well, it'd be $5.50. Okay, so the median is $5.50. The mode. On this one, the mode will be what happens most often. Let's see, we got 350, 425, 5, 6, 650, and 975. Nothing happens more than once. So there is no mode here. There is no value that happens most often. Okay, some vocabulary. Population. When we're dealing with statistics, which we're getting into, a population is an entire group of people or objects. For example, all the pins BIC has manufactured since 1950 would be a population. Every single pin, no matter what has happened to it. A sample. This is sample as a noun. It's part of a population. A sample of BIC pins would be the BIC pins sold in Texas in 2008, which there were probably several 100,000 of them. Census. A census is data gathered from the entire population. It's called a census. In fact, since it's 2020 this year, the U.S. is doing a census this year where they gather data from the entire population. So for a census, BIC pin production according to BIC's company records. So they would have information on how many pins they've produced in total. So they would have the census records on that. A sample as a verb, so to sample something, is to gather data from a sample. So, for example, data gathered from Texas retailers in the year 2008 about the sale of BIC pins. A parameter is summary information about an entire population. So it could be the relative frequency of red BIC pins ever produced according to company records. Okay, and then statistic. This is what we are going to be studying this unit. It's summary information about a sample. The relative frequency of red BIC pins sold in Texas in 2008. Okay, this next statement is about why we study statistics. A sample is often used when a census is too difficult or impossible to do. The study of statistics is the process of using samples to calculate statistics that estimate parameters and make inferences about a population. Now, if you have a small enough population, you can just figure out the parameter. Let's take maybe just the members of your household. There's a finite number of those. It's easy to survey them and get the information from them. And you can do all kinds of calculations with that. Those wouldn't be statistics. They would be parameters of your household. You know, the average age, the average height. Those would all be parameters. But if you want to know the average height of students at a school, you would want to use a statistic for that, because otherwise you'd have to gather data from around 900 people. So on these, we're going to identify what would be the population and what would be the sample. So A, the students in a school and the students in a math class. Which of these would be considered the population, and which one is a sample of that population? Well, if we are talking about students in a school as the population, you could survey just one math class within that school to get a sample. And by the way, we'll talk later about whether that's a good sample or not. Everybody's required to take a math class, so that does help it possibly be a good sample. Okay, let's look at our next example. the grizzly bears with GPS collars in a park, and the grizzly bears in a park. Which of these would be the population, which would be the sample? Well, the population would include all grizzly bears that are in the park. And then the sample is those that have the GPS collar on them. And they use those GPS collars to keep track of the population of the bears. It looks like in that picture right there, they have a helicopter. They'll sometimes fly around and tranquilize them from the air and be able to land and take data from them. But we will, in the next couple of weeks, we'll talk about how they use statistics to count the number of animals in a certain area without having to capture all of them to count them. Statistics is about gathering information without having to gather all the information. Okay, we've got 150 quarters and all the quarters in circulation, which this would not be a picture of. This would just be a small part of it. But all quarters in circulation would be the population of all quarters. And just 150 of them that have been picked would be a sample. Okay, all the books in a library and 10 fiction books in a library. Well, the population would be all the books. And if we want to know something about the books, maybe we take a sample of 10 fiction books. May not be the best depending on what you're trying to figure out. If it's all the fiction books you want to know about, maybe picking 10 fiction books would be good. But there are things that wouldn't be included in the fiction books, like nonfiction stuff, history and whatnot. Okay, identify the population in the sample. The members of the U.S. Congress and the citizens of the U.S. Well, the citizens of the U.S. would be the population. And we have a representative republic in which members are elected to the U.S. Congress to represent us. And they are a sample. They are the sample that actually governs. Well, they legislate. I guess the president governs, the governor governs, the local mayor governs. All purchases made at Walmart today and 15 purchases made at Walmart today. Well, if we're studying some information about purchases at Walmart, all the purchases within a day would be the population, and only 15 of them would be a small sample that we could take. Now, if you have access to Walmart's records, you could get that population information, be able to do some statistics on it, or figure out some parameters. But if you're trying to figure out things about all Walmarts everywhere, you'd probably want to go to a few different Walmart stores, because different regions will have different shopping preferences. Just people will be buying different things here in Utah than they might be buying in California or New Mexico or New Jersey. Would you survey the population or a sample? Okay, earlier I mentioned that we use statistics when it's pretty much impossible or very difficult and expensive to survey the entire population. So you want to know the mean height of your first hour class. Well, your first hour class, probably between 20 and 35 students. You could measure all those given enough time. That one, I would go ahead and survey the population. Getting information from 35 people is doable. It's a little time consuming, but it's not going to be expensive. So I would go with the population. You'd get more accurate statistics out, accurate data. Okay, you want to know the median. This is example 806. You want to know the median household size in Utah. Okay, households in Utah. There's probably 300,000 to 500,000 households in Utah. Are you going to be able to gather data from all of Utah? Well, I don't think so. This one you would want to use a sample to gather your data and use that to make inferences about the population. Example 807. You want to know the mean adult male height in the U.S. Okay. adult males in the U.S., there's about 100 million of us. So trying to gather data from all of them would be, I'm not going to say expensive, I'm going to say impossible. It's not going to happen. So you're very limited here. You would have to use a sample. It's just unrealistic to try to gather all that data. But they do have a lot of this type of data. People go to doctor's offices, maybe they get their height measured, that data gets passed on, and they do have average statistics for, the average height of an adult male, the average weight, a bunch of averages that are known because of some samples that have been taken. Quite large samples, in fact. Okay, example 808. You want to know the favorite ice cream flavor in your family. Now, your family is not going to be very many people. I mean, even if it's a large family and it's like 15 people, you can still just ask all of them. So this one I would definitely just go with the whole population. Just ask everybody, figure it out, don't leave anyone out, and get a pretty good idea of what the favorite, well, actually not just a pretty good idea, you'd know what it is, except that favorites change from time to time. Okay, main idea. We use statistics to make inferences about a population by assuming that relative frequencies in the sample are roughly the same as the relative frequencies in the population. We also assume that the measures of center for the population will be close to the measures of center for a sample. Just as we discussed with experimental probability, the law of large numbers applies. The larger the sample size, the better, so long as the sample does not favor any particular subset of the population. So we did experimental probability in the last unit, and statistics is really closely related to experimental probability. So let's take an example where we're going to use a statistic to estimate a parameter. You ask 75 randomly chosen students how many movies they watch each week. There are 1,200 students in the school. Predict the number N of students in the school who watch one movie each week. Okay, so because we are assuming that the relative frequencies are the same, the relative frequency in the sample for one movie a week is 21 people out of 75, because they surveyed 75 people and 21 of them said one movie. Now we are going to assume that in the population the same relative frequency occurs, but we don't know how many people it is out of 1,200. So this is where the statistics become powerful. The ratio in the sample is going to be pretty darn close to the ratio in the population. Close enough we're just going to assume that they're the same. Now, statistics aren't perfect. It will possibly be a little bit off, but it's pretty close, and it's better than asking everybody and taking all that time and effort. So we can just solve this using cross products. 21 times 1,200. That's 25,200. And we're going to divide by 75. And we get x equals divide 75, 336. So we would expect 336 students watch one movie, was it per week? Yeah, one movie per week. So that's the estimate. 336 students watch one movie per week. Now, if the actual parameter for the school is that 350 students watch one movie per week, that would be reasonable. It's pretty close to 336. But that's how statistics work. Okay, use the given statistic to make an inference about the population. 25 randomly selected students are surveyed about their interest in an after-school activity. 5 students express interest. The school has 850 students. How many total students from the whole school do we expect to be interested in the after-school activity? Okay, in the sample, we have 5 out of 25 that are interested. In the population, we're going to assume that there's the same ratio, but we don't know how many people are interested, but it is out of 850. So we're going to assume this is equal. You do your cross products. 5 times 850 is 4,250. And we can divide both sides by 25 and divide 25, and we get x equals 170. So we would expect 170 students to be interested in the after-school activity based on our statistics. Okay, example 8:10. A sample of 50 LHS students, that's some sort of high school, Lehigh High School maybe, with after-school jobs found that they had a mean income of $120 per week. What is the expected combined weekly income of 300 students with after-school jobs at LHS? All right, on this one, the sample had a mean of $120 a week. We are going to assume that the population also has a mean of $120 per week. So we can take $120 per week, and we're going to do it over the 300 students with jobs. All we need to do is multiply by 300 students, because we're going to get the combined expected weekly income. This would give $36,000. So we expect that students, the 300 students with those jobs, end up earning a total of $36,000 a week. Okay, on your assignment, number 1, you're going to find the mean, median, and mode of each data set. There are 6 different data sets. You may need to use a separate piece of paper to work these out because there's not a whole lot of room there. Number 2, identify the population and the sample, A, B, and C. Number 3 is a probability problem. Number 4, proportions. Number 5, fractions. Number 6 looks like you're going to solve and graph. Number 7, tell me whether you would survey the population or a sample and explain why. And number 8 is a question about food and a survey that was done on food. Thanks for watching.